Hi dear students of plus 2 medical, non-medical and respected teachers. So today I am going to discuss Bohr's model of atom after Thomson model of atom and Rutherford model of atom. So first of all, what are the various postulates of Bohr's model of atom? First postulate is that Bohr's model, according to Bohr's model of atom, each atom consists of a positively charged central core situated at the center of the atom, which is responsible for almost entire mass of the atom, called nucleus. So nucleus is the central part of the atom, which has size of the order of 1 Fermi as calculated by Rutherford. Second, law of orbits. According to Bohr's model of atom, electrons revolve around the nucleus in certain permitted orbits, also called stationary orbits. They are also called stable orbits, and the necessary centrifugal force is provided by the electrostatic force between the nucleus and the electron. Third point, what are stationary or stable or permitted orbits? So according to Bohr, stationary orbits or permitted orbits or stable orbits are those for which angular momentum of electron is equal to n times the factor h upon 2 pi, where h is called Planck's constant, v the velocity of electron or the radius of the orbit, m is the mass of electron, and n has integral value 1, 2, 3 and so on, and this n is known as principal quantum number. In other words, for stationary orbits, angular momentum is quantized. For stationary orbits or stable orbits, angular momentum of the electron is quantized in nature, and that's why this mvr is equal to nh upon 2 pi is called Bohr's quantization condition. So if you are asked to state Bohr's quantization condition, it means it states that angular momentum of electron in an orbit is equal to integral multiple of the factor h upon 2 pi. H is Planck's constant and h upon 2 pi is known as Dirac constant. And fourth, now according to Bohr's model of atom, when electron jumps from any higher orbit, stable orbit, to lower stable orbit, energy is emitted in the form of radiations, and when electron jumps from any lower orbit to higher orbit, energy is absorbed. So amount of energy emitted or absorbed when electron jumps from any stable orbit to another stable orbit is given by h nu is equal to E2 minus E1. This is known as Bohr's frequency condition. E2 is the energy of the electron in the higher orbit, or E1 is the energy of electron in the lower orbit. So h nu E2 minus E1, or you can say E1 is the initial energy in the initial orbit, E2 is the final energy. So h nu, amount of energy or radiation emitted, is equal to h nu is equal to E2 minus E1. This is known as Bohr's Bohr's frequency condition. So we said Bohr's quantization condition, mvr is equal to nh upon 2 pi, and Bohr's frequency condition, h nu is equal to E2 minus E1. Lastly, since total negative charge of electrons is equal to total positive charge of nucleus, so atom is electrically neutral. So these are the 5 postulates of Bohr's model of atom. Now we will discuss theory of Bohr's model of atom, especially for hydrogen atom, which is true for all atoms. So for hydrogen atom we will take Z is equal to 1, atomic number is equal to 1. So first of all, we will calculate radius of the stationary orbits, expression for radius of the stationary or stable orbits. For that, suppose we have an electron revolving around the nucleus in an orbit of radius r. As we know that necessary centripetal force is provided by the electrostatic force of attraction between nucleus and the electron, as given in equation number 1. Now, to find radius of stationary orbits, from this Bohr's quantization definition, we have mvr is equal to nh upon 2 pi. We have to find expression for r. Or from this equation, v is equal to nh upon 2 pi mr. And if we substitute the value of this v in equation number 1, so we get m upon r is equal to n square h square, v square means upon 4 pi square m square r square, which is equal to k constant 1.4% is taken as k z e square upon r square, right hand side. And we simplify it, 1 m cancels, r square cancels, so we get r is equal to n square h square over 4 pi square m e square, and for z is equal to 1. For any atom, we can take z here also. So r is equal to n square r square h square, sorry, not r square, n square h square over 4 pi square m k e square. As all pi, m, k, e, h, all are constant, it means it is very clear radius of the electron of any stable orbit is directly proportional to square of the principal quantum number. So r is directly proportional to n square, very very important. So this gives the radius of permitted orbits. So it means radius of permitted orbits will not be any number, it will be 1:4:9:60 ratio. The first radius is r naught, that is called Bohr's radius. Next radius of the second orbit will be 4r. Third orbit will be 9r. Next orbit will be 16r and so on. Then 25r. So radius of orbit is directly proportional to square of the principal quantum number. So you have to remember this. So for n is equal to 1 and for h atom, this r comes out to 0.53 angstrom. So this is known as Bohr's radius. First orbit 0.53 angstrom. So next radius will be 4 times 0.53. Next will be 9 times 0.53 and so on. So this is expression for r and how it depends upon principal quantum number. It means radius of orbits is directly proportional to square of principal quantum number. Then velocity of electron. To find velocity of electron from equation 4 and 5. Now we have v is equal to nh upon 2 pi mr. Substitute value of r from this equation that we have calculated. So it will be n square h square, the denominator 4 pi square m k e square. Mm cancels, pi 1 pi cancels, h cancels, 1 n cancels. So we get v is equal to 2 pi k e square upon nh for h atom, taking z is equal to 1. Or if you multiply and divide by c, so this 2 pi k e square upon ch is known as alpha, fine structure constant. So we can see v is inversely proportional to n, okay, all other constants. So it means the radius of stable orbit is directly proportional to square of the principal quantum number, whereas velocity of electron in an orbit is inversely proportional to its principal quantum number. As principal quantum number increases, velocity of electron decreases. So for n is equal to 1 and taking this constant, so v is equal to 1.137 times e, because 1.137 is equal to alpha is called fine structure constant. So you can calculate by multiply c divided by c. So then constant can be taken as alpha. So c upon n this side. So in general, v is equal to alpha c upon n. Alpha, value of alpha is 1.137. So when n is equal to 1, first orbit's velocity will be 1.3137 times velocity of light. And in second orbit, n is equal to 2, velocity decreases and so on. So it means as n increases, velocity of orbital electron will decrease. It is maximum in the first orbit. So and alpha is called fine structure constant. Its value is 1.137. Okay. Then frequency of electron. The frequency of electron means as V is equal to R omega, or R omega is 2 pi nu. So therefore nu is equal to V upon 2 pi R. So substitute the value of V here 2 pi R. That will be 2 pi K square upon NH. Pi cancels. So it comes nu K square upon NHR. Or you can see frequency is also inversely proportional to principal quantum number. Frequency is also inversely proportional to principal quantum number. So E is proportional to 1 by N. So more is the principal quantum number, less is the frequency, which will be emitted or absorbed during when electron jumps from higher orbit to lower orbit, or lower orbit to higher orbit. This is frequency of orbit. Now we have to find total energy of H atom. Total energy of electron in an orbit of H atom. So as electron revolving around the nucleus possess two types of energies, kinetic energy as well as potential energy. Now as mv square by r, centripetal force is provided by the electrostatic force k z square by r square. So r cancels. So from here we can find half mv square as kinetic energy of one electron, that will be k z square upon 2r. Then electrostatic potential energy k z minus e into r. So minus k z square upon r. Total energy will be equal to k z square upon 2r minus k z square upon r. Simplify minus k z square upon 2r. Simple mathematics. Using value of r from equation number 5. So we have E is equal to k z square upon 2. Substitute value of r m square s square in denominator, 4 pi square m k z e square. Or if simplified, it will be minus 2 pi square m k square z square e4 n square s square. Or E is equal to minus 13.6 z square upon n square electron volt. You have to remember this relation. So no need to remember all this formula. Remember this relation. E is equal to minus 13.6 z square upon n square. For H atom, z is equal to 1. So for H atom, total energy of the electron is given by E is equal to minus 13.6 upon n square electron volt. It means total energy of orbital electron is inversely proportional to square of the principal quantum number. And for n is equal to 1, E is equal to minus 13.6 electron volt. Moreover, total energy is negative. It means electron is bound to the nucleus. It cannot leave the nucleus. Electron is bound. And energy is negative. And this is the minimum energy attained by the electron in the first orbit or in the ground state. So ground state energy of electron in H atom is minus 13.6 electron volt, which is the minimum possible energy. So it means if you have to take electron from ground state out of atom, so you have to apply plus 13.6 electron volt energy, and that is called ionization energy. That is the amount of energy required to be given to an electron in the ground state so that it goes out of the atom. That is ionization of atom takes place, is called ionization energy, or ground state energy is minus 13.6 electron volt, which is minimum energy. So minimum energy is a stable energy state. So this is all about Bohr's model of atom. Bohr's model of atom, its postulates and theory of Bohr's model of atom. Thank you. Good luck. All the best. Be happy. Stay tuned. Till next video. Sarvat da Pala.